Us Canadians, we live for the summer. It's only nice like 4 to 5 months out of the year here, so while it's warm, I like to spend as much time as I possibly can outside. But I also like to play video games and watch movies, which is traditionally more of an indoor activity. So what's a conflicted Canadian nerd like myself to do? Well, I think the answer is actually kind of simple. I need to build an outdoor home theater, and it needs to fulfill some very specific criteria. The first of which is that it needs to be portable because I want to be able to take this thing on the road with me when I go to cottages with my friends. And also, once it starts to get cold again, I want to be able to bring it inside and pack it away for the winter. So for the foundation of today's project, I want to use a really cool product from the sponsor of today's video, DJI. This is the DJI Power 1000, and it is going to power our entire outdoor home theater. And for a long time too, because this thing has a truly insane capacity and it can even output up to 2200 watts. But we'll talk more about specs and figures later, because for now, I have to figure out the first challenge in this project, packaging. So here's my idea. I want to build everything on top of the Power 1000. It's a nice stable unit with all of its weight down low thanks to the battery cells, and it even has these convenient handles to pick it up and move it around. As far as platforms go, it's honestly pretty perfect, but obviously they didn't design it with this in mind. So the first thing I need to do is build a filler piece that'll level out the top and give us something that we can build off of. I started by measuring out and modeling the Power 1000. It's not a perfect one-to-one model, but all the key measurements are there. Originally, I had planned to 3D print this filler piece, but I quickly realized that it would be too big to print as a single unit. I could split it up into 2 pieces and then join them together afterwards, but instead I opted to just cut it out of wood on my CNC. I already had the wood left over from another project, and I think doing it this way will not only make it look better, but will also make some of our future attachments a lot easier. And just for fun, I decided to power my dust collector using the Power 1000. A little bit of post-processing and smoothing, and we now had a badass looking filler piece. Let's see how it fits. So we'll just slide this in here like that, and there we go. We have a nice flat surface that we can build up off of. Now, let's talk about the screen for our outdoor home theater. I'm thinking big. I'm thinking really big, like 100 inches big, which I'll grant you doesn't sound all that portable until you remember that there's actually a lot of decently affordable compact projectors on the market. This is the X-Gimme Halo Plus. And given its compact size, it's a surprisingly bright projector. It's got a built-in operating system for streaming media, and it even has its own built-in speakers battery. The problem is the battery life is pretty limited at only 2 hours or so, and the speakers aren't powerful enough for outdoor use. But that's okay, because we can use our Power 1000 here to power it almost indefinitely. We'll talk more about the speakers later, but for now, let's talk about how we're going to set up the projector. It can just go right on top here like this, but then its power adapter is just floating freely and honestly looks pretty ugly. So I created this enclosure to clean things up a little bit. I gave it plenty of ventilation so the adapter should stay nice and cool, and using these screw holes we can attach it securely to the wood below. But then I had another problem, and that's why you see this cutout right here. It only takes up half the platform, so on the opposite side, I designed another filler piece. But then that seemed like a big waste of space, so I actually turned it into a functional drawer. This will be great for storing things like HDMI cables and USB-C charging cables. And I guess I didn't mention this earlier, but the projector actually has an HDMI input, so we'll be able to hook up some really fun stuff to this thing. For now though, I had to print those parts that I just designed. And I take a lot of flack for having 2 3D printers, but I think this is a great example of why it's so beneficial. Since I'm designing this project to be modular, I can basically double my throughput by printing different parts on different printers at the same time. So check this out. This goes here, this slots into it, our storage drawer goes in here, and our PSU goes in here. A couple of lids, clean up the top, and now we are ready to move on to the next phase of this project. The speakers, because like I said before, the speakers in this projector aren't particularly powerful, and I don't think they're gonna be strong enough for outdoor use. So I wanna build an integrated custom 2.1 sound system. That means we will have a left and a right channel powered by these 3.5-inch drivers. In a simple system like this, you want to use full range drivers that output both mids and highs because we're not going to have dedicated tweeters. And these should get louder than basically any Bluetooth speaker on the market because combined, they'll output up to 80 watts of sound. But when you're watching movies and playing video games, you also want to feel those explosions and low-end rumble, so I'm also going to include this compact 3-inch subwoofer. And don't let this thing's compact size fool you either, because it's capable of outputting 30 watts all by itself. With this trio of speakers here, we should have all of our bases covered for great sound, but now we've run into a new issue. Our projector here is not going to output enough power in order to run them. So I also got this compact plate amp. The idea here is to take this 3.5mm output from our projector, run it to the amp, and then have that power our speakers. And this thing is pretty cool all on its own too. It's got a Wi-Fi and Bluetooth connection, so it supports streaming from all your favorite services. That means that I could also use this as a giant Bluetooth speaker for outdoor parties and stuff like that. Before I went to the effort of designing an enclosure for my new speakers, I figured it'd be a good idea to hook them all up to my bench and make sure this combination of parts would actually work. That meant soldering these connections onto my drivers and then running them back to the amp. A little dot of flux on each of these speaker connectors ensured a good solid connection by clearing away any impurities and surface oxidation. So one thing I didn't see coming is that this thing requires an app to set up. Hopefully it's relatively simple. Just download it now and connecting. There we go. Okay, yeah, that one works. This one works over here. And yeah, we got the sub going too. Sweet. All right, now the real question is, if I press this mode button and we go back to line in, and I power on the projector, yeah, good sound, because if I cycle through the menu, I can hear the little clicks of the menu on the speakers. It actually works. That makes me really happy. But you know what doesn't make me happy? These ugly wires that are sticking out of the front of the plate amp. So I actually want to take this thing apart and see if we can fix that and streamline this thing a little bit. By removing a few screws and a couple of protective plates, I revealed the PCB that all the ports connect to. And here we can see that these connectors are actually relatively simple circuits. By probing these points, I was able to figure out which terminals were the positives and negatives for the power supply, and then from there, all I had to do was solder a couple wires onto them and then back to this generic barrel plug adapter. With that in place, I now had an internal plug that I could use to supply power to the amp. And the 3.5mm aux input was much the same, just a little bit smaller. I figured out which contacts were responsible for the left and right channels, as well as the ground, and then with a steady hand, I soldered a wire to each one. I then connected everything back to the projector and tested to see if my custom wiring worked. Okay, quick test. And yeah, looks like both of our auxiliary hookups are now working. So now, I think we can move on to the enclosures. And the first one is going to be for the amp, and compared to all the others at least, this one is relatively simple. It's got some vents around back for dissipating heat and some cutouts for routing wires. But don't let its simple shape fool you, because this little box is going to be the cornerstone of our modular design. So this screws into our storage containers down below using these screw holes and serves as our primary anchor point. See how it's got these fingers and screw holes on either side? Well, those are going to lock it into the speaker enclosures that are going to house the left and right drivers. So now let's talk about our speaker enclosures, because those are significantly more complicated. Every speaker driver has its own optimal enclosure volume. Or, well, actually really it has two. It'll have one for a ported enclosure and one for a sealed enclosure. Now, because we're building a relatively compact speaker system, I'm gonna opt for a sealed enclosure, which is more compact and should, in theory anyways, have a more precise and articulate sound, but that comes at the trade-off of a little bit of loudness. Now, here's the cool thing about 3D printing your own speaker enclosures. Most DIY audio projects are just square wooden boxes, but that isn't the optimal shape. Because you have a bunch of parallel surfaces, you can end up with a lot of standing waves and resonance inside your speaker cabinets, which then degrades sound quality. So for these speakers, I'm actually gonna add a bunch of random shapes and surface deformations inside the speakers to break up those standing waves. That should make them sound a lot better. And because I have a full 3D model here, I can very accurately calculate the internal volume of each enclosure to ensure that we're right in that optimal pocket. So now that all the design is done, let's 3D print these bad boys and see how they all fit together. Now, you might be thinking that because these speakers have such thick walls and all that complex geometry that they're gonna waste a ton of plastic, but that isn't really the case. it's pretty rare to print anything 100% solid. Most of the time, you'll just have thin exterior walls and then an infill pattern for any solid areas. This saves a ton of plastic. In my case, I'm using the gyroid pattern because it's one of the strongest available and it's also very dimensionally stable. So printing each one of these enclosures actually ends up being pretty economical and only costs me like $2 to $3 in material. I've still got a couple of tricks up my sleeve for improving sound quality later, but for now I wanted to test assemble everything and make sure that all my calculations were correct. To make my life as simple as possible, this whole project will be assembled using M3 screws. And a really handy trick I've learned is that you can just make all of your screw holes 1/4 millimeter smaller than your hardware. That way, as you screw them in, they'll just cut their own threads. It works really well and saves a ton of time when you're 3D modeling. All right, so there we go. Everything is now screwed and locked together, and honestly, this whole thing is surprisingly solid. So now, let's talk about where we're going to put the subwoofer. As you can see, there's not really any more space on the back face of the system, so we're gonna have to take advantage of a little quirk of human physiology. You may have noticed that it's actually really hard to tell where a loud, bassy sound is coming from, and that's because humans are just really bad at telling the directionality of low frequency sounds. That's why you can basically put the subwoofer in your home theater anywhere. So for this sub, we're actually going to spin this around and put it right about here. Now, the subwoofer's enclosure has its own unique optimal internal volume, but outside of that, its design is very similar to all of the other enclosures. So after 6 hours of printing, it was done and I was ready to start putting everything together. The subwoofer goes here, gets screwed in place, then our wire for it gets routed through the right speaker enclosure and back to the plate amp. Everything gets locked together with a couple of set screws and we are looking good. I also printed out lids that show off each enclosure's unique internal shape. But what about this blank space over here? Well, for that, I'm actually going to do two things. First, I redesigned this lid to add more ventilation for the PSU enclosure, seeing as there's now not one, but two PSUs inside of it. And then second, I designed a cradle that will hold the remote for the projector. That way, I always know where it is. So there we go, that's our completed unit. Or, well, not actually, I still have a few things that I wanna do, but in order to do them, we're gonna need to get a little bit messy, so I think we better head to the shop. The first thing I did there was make that piece of white maple fit the rest of our black and gray color scheme a little bit better. In order to do that, I hit it with a couple of coats of a dark stain. So while we wait for that to dry, the next thing I want to do is hopefully improve the sound quality of these speaker houses a little bit. Despite my engineering with the diffraction nodes inside of them, just due to the fact that these are made out of plastic, they're pretty rattly. So in order to fix that, I want to use a product that I didn't even know existed until a couple days ago. This is Boom Mat, and it's essentially Dynamat, but in a can. Or more specifically, it's a flexible rubberized coating that you can spray onto any surface to help reduce vibrations. Traditionally, this is for automotive applications, but practically, I can't see a reason why it wouldn't work here as well. When it comes to sealed speakers, the only vibrations you want to hear are the ones coming off of your drivers. So this stuff will add mass to the walls of our enclosure and help to reduce internal resonance. It was a bit messy to work with, but overall it was a lot easier than trying to line these speakers with any other sound deadening materials. The next thing I wanted to tackle was making all of our 3D printed parts look less like 3D printed parts. So I grabbed some high building filler primer and loaded it up into my sprayer. The idea here was to fill in all the horizontal layer lines created by this 3D printing process. I sanded between each coat to knock down any high points and just kept layering on the primer. Once it was smooth to the touch, I finished things off with a few coats of matte black paint. Now, in my last video, I showed how much easier it can be to simply have parts like these professionally 3D printed for you, and I would have done that here too, but I was on a tight timeline and those services can take a couple of weeks. So anyways, with all of that stuff taken care of, I headed back home to do the final assembly. All of the enclosures got screwed together, the drivers got secured in place, and then I had to solve a problem. These are supposed to be sealed enclosures, but I had a bunch of holes in them for routing wires. So in order to prevent the sound waves from leaking out, I sealed each chamber with some clear silicone. With that final step taken care of, I screwed on my covers and connected everything back to the plate amp. A little bit of cable management, and even that fit nicely in place. All right, look at this thing. This looks so cool. It's very industrial and raw looking with the exposed wires. So listen to this. For 3D printed enclosures, these things are not resonant at all. They're very well dampened, and I think this thing is going to sound great. So I think at this point, the only thing left to do is to test this thing out. Ew. Except I've been using it quite a bit and it's quite low. So you know what, before we test it, why don't I show you one of the cooler features of this product? Not only can you charge the Power 1000 from a conventional wall outlet, where it'll suck down up to 1200 watts of power, but you can also charge it from the 12-volt plug in your car, perfect for charging it on the way to the campsite. Or you could charge it in quite possibly the coolest way using this little accessory that I'm screwing onto it right now. This is what DJI calls the MPPT, or the solar panel adapter, and it lets you charge the Power 1000 with up to 3 optional solar panels. That way you can keep it topped up even when you're completely off the grid. In my shady backyard, it wasn't able to output much, but once I moved it over into my much sunnier driveway, it was easily matching the car charger, and that was just with a single panel. But then I noticed something interesting. So while I was out there filming the charging B-roll for the Power 1000, I noticed something kind of interesting about it. So I want to pull a couple of panels off and see if I'm right, because it gave me a little bit of an idea. Something that I really appreciate about the Power 1000 is that it seems to be made with repairability in mind. All of these screws are easily accessible and the whole thing can be torn down in less than a couple of minutes. That means that in the future, if any cells or any of the other components wear out, they can all easily be replaced. With so many companies going in the opposite direction, I applaud DJI for their design here. With the control panel now loose, I was able to pull it back and confirm my suspicions. I knew it. So behind the front control panel, you have this truly massive and complex transformer up top that is responsible for supplying all the various voltages and currents to the ports on the front panel. And because there's so many, well, you need a pretty complex transformer to do that. Below that, down here, you have a compartment that is filled with all the battery cells that are responsible for delivering the 1000 watt hours of this crazy big battery. But the thing that I was actually the most interested in is tucked away back here. Now, it's a little tricky to see, but that is actually some active cooling. There's a fan back there. These fans keep the insides cool during normal operations, and they must be whisper quiet because the Power 1000 only generates 23 decibels of noise while it's charging, which is definitely an advantage for a home theater setup like mine. But those fans also got me thinking, what about if I want a game on my outdoor home theater? I'm gonna need somewhere to put my console. So I thought, why not utilize these 2 accessory ports when I'm not using the solar charging, and then we can also take advantage of that active airflow. 30 minutes of 3D modeling later, and I had a design for a very basic but functional game console holder. I printed it out, screwed it in place, and then tested to see if both my Nintendo Switch and my ROG Ally would fit. And one of the nice things about the Power 1000 is that it's got dual 140 watt USB-C power delivery ports right on its front face. These allow for ultra fast charging of all your mobile devices. So it would be no problem for me to charge both of these devices at full speed at the same time. All right, so now that we got that all sorted out, let's head outside where I'm gonna set up the screen and then we can test this thing out. As it turns out, portable projector screens are actually pretty affordable. For less than $100, I was able to get this 100-inch screen and the integrated mounting stand. So with my outdoor living room set up all ready to go, the only thing I had to do was wait for the sun to set. And once it did, oh man, I gotta tell you guys, this thing is sweet. One of my favorite features of this projector is its autofocus and auto keystone system. Getting it set up took less than 30 seconds. Now, I live downtown, so there was a ton of traffic noise and external light, but even still, the projector and the speakers were easily able to overcome all of that and create an awesome viewing experience. Honestly, I was more concerned with annoying my neighbors, but so far so good on that front. Under full load, with the brightness and volume cranked, this whole setup was drawing less than 100 watts of power. So that means I could run my portable home theater for over 10 hours on one full charge of the Power 1000. Once I took the time to balance the bass and treble on the rear mounted control panel, the speakers sounded really good. I think this thing is going to make a great Bluetooth speaker for garden parties and stuff like that. And honestly, playing Smash Bros outside on a 100-inch screen is something that just has to be experienced. One of the big reasons I picked this projector in particular is because it has really low input latency, so it's great for gaming. And being able to enjoy all of this without worrying about plugging anything in was truly a treat, and that's all thanks to the Power 1000. So yeah, I think I'm gonna get a lot of use out of this thing, both here and on the road this summer. That being said, I still think there's a few things that I could have done better. I didn't think DJI would appreciate it, but had I drilled a hole in their brand new battery platform, I could have run these wires internally and cleaned things up quite a bit. And it honestly wouldn't have even been that hard to do. I also could have installed some mesh over these front drivers to keep kids and, well, careless adults from messing with them. And then finally, I realized I have just enough space in that storage drawer for a mini PC or a Raspberry Pi 5 like this one. I think this thing would be really cool if it had its own internal gaming system built right into it. In fact, that might actually make for a good part 2 to this project, so let me know down in the comments if that's something you'd like to see. Big thanks to DJI for sponsoring this video, and I will see you guys in the next one. Peace.